Hey everyone, Bob Roberts here. I hope you're all having a great day today. I want to welcome you to our third and final video on space from the Civil Air Patrol Aerospace Dimensions Module 6. Now, while this video is geared towards our cadets who are learning for their promotions test, anybody who's watching this video who is interested in living and working in space can also learn a lot. Now, if you might be interested in learning more about Civil Air Patrol and our cadet and senior programs, I'd like you to go visit gocivilairpatrol.com or send me a message and I'll be happy to answer any questions that you might have. With that, let's just jump right in. Now, in this video, we will be focusing in on the space stations and how humans are working in space. Now, this is kind of a continuation of the information that we have already discussed in Chapter 2 for manned spacecraft, but we are going to focus a little bit more in on the space stations themselves. For nearly as long as humans have thought about being in space, they have thought about what it might be like to live and work in space. Now, as a race, we are starting to get a lot closer to the realization of space hotels and the average human being being able to go into space. With the cost of space travel, while still extremely expensive today, they are starting to show signs of being able to be reduced, thanks in large part to the reusable rockets and improved material sciences and computing technology. Now, Elon Musk is often quoted as saying, if you had to throw away the airplane every time you used it, it would be really expensive to fly. Now, we actually did a video on reusability, and I'm going to throw a link to that up here. In addition to being a fun and exciting future vacation for you and your family, space stations have a practical benefit to them as well. They can be used, as well as they're being used today, for scientific research and as bases for launches of future missions, and even some military reasons. Now, hopefully they're not going to build a Star Wars Death Star because those things always blow up. So the award for mankind's very first space station was the Cellular 1 in April of 1971. And it stayed in space for about 6 months. And cosmonauts, or Russian astronauts, stayed in Cellular 1 for just 3 weeks. Now, after those 6 months, the Cellular slowly lost its fight against Earth's gravity and began a slow lowering until it reached the upper atmosphere, which, even though there was only a very small amount of air molecules, it's just enough to begin to slow the stations down and force it to re-enter Earth's atmosphere. Thus, given the incredible speeds that is impacting the atmosphere, the friction causes these objects to burn up with only some pieces surviving. Now, unlike our International Space Station today, or Skylab before that, the Cellular was an entire series of small space stations, with later versions staying in space for much longer periods of time. Now, the last was Cellular, which stayed in space for about 4 years, and the cosmonauts stayed for 234 days, which was a record back then, and even longer than most astronauts stay on the International Space Station today. With the Russians learning a great deal from the Soviet space stations, they built their next and last nationally created space station when they built the space station Mir. Now, Mir was launched in 1986, and while most think it was a larger space station, it was actually about the same size as the Salyuts. The Russians were slightly limited based on the size of the rockets that they were using and the size and mass of the components during these launches. They just didn't have rockets like the Saturn V that could get really big components into space. Now, unlike the Salyut, the Mir was actually far more open inside, with it carrying much less scientific payloads. Mir also stayed in space much longer than the Salyuts. Now, it had a lot of significant technical problems over the years, but it did end up staying in space all the way until 2001, or about 15 years in total. We even had 2 American astronauts that stayed on Mir for 2 entire years. I really like to believe that if Sputnik was the start of the space race, it was Mir, another Russian spacecraft, that was the end of it. That happened when the Russian cosmonauts welcomed their American astronaut counterparts into the Mir station. Now, while the Russians got the gold star for their first space station, the USA was just 2 years behind with the US's first space station called Skylab. Now, Skylab was pretty short-lived, however. It was launched in 1973, but it only had 3 different crews visit it, the last of which stayed in space for only 84 days. The goal of Skylab was to simply study how individuals could live and work in space. Now, Skylab itself stayed in space for about 6 years before Earth's gravity brought it back into the atmosphere. Most of it did burn up, but some of the larger components landed in the Indian Ocean, and we were able to recover those pieces. So to be clear, we had Americans on the Russian space stations for over 2 years, and the longest stay on the US Skylab was just 84 days. I think some folks believe Skylab was the more prominent space station when comparing it to Mir. But as you can see, that may not have been so. Now the Europeans didn't want to be left out, so they developed what they called Space Lab. Now, like the name indicates, that's exactly basically what it was used for. It held scientific experiments and was dedicated to performing those hands-on experiments. But to be fair, this was not really a space station in the same concept as the Russian and American space stations. Humans did not live in Spacelab. It floated in space, but was captured by the Canadian arm on the space shuttle and put into the cargo bay of the space shuttle. It used the space shuttle for the life support and living quarters, and you would enter it from a tube that connected it to the space shuttle. The shuttle did, however, have over 20 missions to Spacelab between 1983 and 1998. Since you could set up an experiment and then leave it in space for much longer periods of time, which really was its biggest contribution. Now, as part of all of these activities, a few details became very apparent. Number one is that the space stations were often too small to really live in for extended periods of time comfortably. Number two, also given their smaller size, you had a limit on the size of the crew that could work in them. Number three, they were really expensive for any one country to deploy themselves. Even countries such as the United States and Russia found the programs to be very expensive. Now, given those issues and the new era of space cooperation in place, the international community got together and built the next space station together, all except China, which even today is borrowed from the International Space Station when the US Congress passed a law in 2011 prohibiting them due to national security concerns. But there was a total of 5 different space agencies that contributed to building the International Space Station. They were the National Aeronautics and Space Administration, or what we call it NASA, from the United States, Roscosmos from Russia, the Japan Aerospace Exploration Agency, or JAXA, the European Space Agency, or ESA, from Europe, and the Canadian Space Agency, or CSA. Now, those 5 programs actually represented 15 countries, so it truly was an international effort, unfortunately, without China. Now, unlike the other space stations, no one country owns the ISS. The ISS was built on the backs of the space shuttle, which was able to carry larger payloads and larger crews to help assemble a space station in space. Now, even with that, it took more than 10 years and more than 30 missions to complete the space station. Now, we still have missions planned for the future to expand the ISS. So in my mind, the ISS was the first true space station. The other space stations were short-term or longer-term tests. In addition to the countries that helped build the ISS, there have been more than 240 individuals have gone to the ISS, including 19 countries, 151 from the US and 48 from Russia included. There have even been tourists that have gone to the ISS, and it is just now being reported that Tom Cruise is heading to the ISS as part of a new film. Now, hopefully that film inspired folks to dream about becoming astronauts the same way that Top Gun inspired a generation to want to enlist in the United States Navy. Now, like the other space stations, the ISS is constantly finding a balance between Earth's gravity. It is constantly losing just a small amount of altitude due to the slowing effects of the small amounts of atmosphere present where the ISS operates. But it has programs in place to give itself a slight boost a few times a year to keep it up where it should be. Now, some may ask, why not just put it higher where it doesn't lose its 17,227 miles per hour speed due to air molecules? The main reason is that the ISS simply wasn't designed to be moved into higher orbit, and the Space Shuttle orbiter wasn't able to reach the higher orbits to deliver the modules, and the space station then couldn't be built at the higher orbit, and it's not designed to do the required burns that would speed it up enough to then place it into the higher orbit. Because of that, it stays relatively close to the Earth and could not be used to, say, go to the Moon or Mars. So it sits at about 248 miles from the Earth's surface, 400 kilometers. You can actually see the ISS with the unaided eye in the daytime, but especially well at night if you know where to look for it. There are apps and programs that will alert you when and where to look. Now, I'm going to throw a link to one of those NASA programs that I actually use. I'm going to put that down below. Other than the incredible benefit of working together with other countries, the ISS is the largest and most expensive international peace program the Earth has. And only one thing is actually larger, and that's the United Nations. So the other benefit and goal of the ISS, and really all of space stations so far, really revolves around determining how we live and work in space. If we ever can go outside of our planet and put humans on worlds outside of ours, we're going to have to know how to live and work in space during very long voyages. Now, from dealing with technical issues all the way to just learning how to live with your space roommates for years at a time in a small area, in space, you can't just get out, whenever you want and go for a walk. The space stations have living quarters as well as work areas. They have the areas that you can sleep in. They can even use foot restraints that will allow them to sit at a table to eat without simply floating away. They drink liquids through a straw, just like you would a juice box, and they eat solid foods with a knife and a fork. Not everything is freeze-dried like you would think when you visit the space museums. Now, it's incredibly important to stay physically fit in space, more so than even on the planet, because they are weightless. Their muscles don't get the normal daily workout we do from just moving around. They have to use resistance bands since they also can't use weights, since the weights don't actually weigh anything. Now, there's actually 2 treadmills on the ISS, and there's also an exercise bike. Now, they also have a lot of work to do, and they are kept pretty busy throughout the day. There's always additional science experiments that scientists that are on the Earth want them to do up in space. They often will have to work and even repair satellites, as well as the science experiments on the ISS. Now, the astronauts have a 5-day and 10-hour workday, as well as a shorter 5-hour workday on Saturdays. Now, since they would just float away, they don't sleep in a normal bed. They sleep in pretty much what's a sleeping bag that they just zip themselves up into. Now, even simple things like taking a shower and brushing your teeth in space require different technologies and procedures. Now, I'm sure that we would all find it incredible to just sit on the ISS and watch the Earth spin beneath us all day. I also then imagine that after a while, humans just like our habits, and living on the ISS would just become part of their habits and their norm, as amazing as that is for us to think about. And they would develop their own habits. So just like if you were stuck inside your house all the time, you'd want to get outside every once in a while. The ISS is pretty big, but it's not much bigger than a big house. And that is true for these astronauts as well. Now, they can go outside the space station while wearing a spacesuit. And the spacesuits do keep a livable environment for them when they are in space. Now, we have a nickname for this activity we call a spacewalk. But the formal term is extravehicular activities, or EVAs. Now, the science for developing better and better spacesuits is crucially important. The current spacesuits are very large and very bulky, making it a very slow and difficult process to work in them. Now, here's an example. Put a coin on your table. Now, pick it up with your hand. Easy. Now, put on 2 pairs of the biggest winter gloves you can find. Stuff your hand into them. Now, try to pick up the same coin. You're going to find it a lot more difficult. You lose the feel of your fingertips, and the bulk of the fabric makes it harder to grip. The astronauts' gloves are even much worse than that little experiment. Therefore, they have special tools that are created to perform many of the tasks. Even special containers that trap screws, because while you can just pick up a screw you dropped on the floor, in space, that becomes space junk. That might develop an orbit. It might hit you or a satellite and break something, or worse. The training that the astronauts go through have very expensive planning for these EVAs. They often will use massive pools with recreations of their jobs that they have to do, and they will train on the ground for very specific tasks once they're in space. Now, spacesuits have changed a lot over the years. They have gotten lighter and more mobile. They range from pressure suits that are not designed to be worn in space, but worn inside of spacecraft, to self-contained suits that carry everything to survive for extended periods, such as water to drink, oxygen to breathe, radios to communicate. We even designed our very first jetpack so that astronauts could fly in space on their own. We call this the MMU, or the Manned Maneuvering Unit. Now, the very first one was used in 1984. The MMU, however, was only used 3 times due to safety concerns. Now, there's a smaller and simpler version called the Simplified Aid for EVA Rescue, or SAFER, which can be used if an astronaut accidentally becomes separated from the walls of a space station or satellite. Now, in just the last few years, the pressure suits in particular have seen major advances in material sciences and technologies, and they are starting to look more like what we originally visioned in our sci-fi movies 50 years ago. All of these programs have a very expensive price tag, but we have gotten a lot of technology back for that price. Many will be used in space on future missions, but a few are applicable for us back on the surface as well. To name just a few: TV satellite dishes, medical imaging devices, visual screening systems, which you probably went through as a kid to see if you have any vision problems when you were young. Ear and IR thermometers. Our firefighting suits are made from fabric originally designed for spacesuits. Some smoke detectors, battery-powered cordless tools. Even the helmets used in American football have used a foam called Tempur foam, which was first used in NASA's airplanes. Now, if you're sleeping on a Tempur foam bed, you can thank NASA. Now, how about your invisible braces instead of the wired ones? You can thank space for that too. They are made from the same technology used as part of NASA's ceramics development. Now, these are just a few small lists of the everyday items that we take it granted for that are advances from space. Moving into the future of the ISS, there is discussion of an end of service date before 2030. I think it was around 2028. But I personally think that it will likely be extended as there is no real replacement that I know of that's in the works currently. But it may happen, so we'll see. We are beginning to look further into space than just low Earth's atmosphere. And commercialization while working on rockets may actually start commercializing hotels for low Earth orbit. Now, the modules talk specifically about the end of the space shuttle program. And to update that, Atlantis did complete the shuttle program on its 135th mission and its final mission when it touched down on July 21st, 2011. Now, the module also talks about some programs that had promised about 10 years ago. Some of those have experienced some significant issues, such as Virgin Galactic, which took a pause after an accident resulting in the death of the 2 pilots. But on a more positive note, they have recently started working in greater effort again on the program. Now, they even just hired an executive from Disney World that was in charge of the resorts. So as you can tell, they are very much thinking and looking to future space hotels. With the work of reusable rockets and even a new SpaceX craft called Starship, which is going to be the difference between taking 7 people to space versus taking 100 people to space. It seems that all of the work we have done to date with the space stations, plus the promise of reusable rockets, might just bring space to a much larger population someday, relatively soon. And with that, we not only wrap up this video, we are wrapping up this Aerospace Dimensions module, and this is the last module in the program. And I hope that you have found these videos helpful. If so, please do hit that like button down below and subscribe for more videos like these. It really does help the algorithm for YouTube. I really appreciate that. So thanks everybody. I hope you're having a great day today, and we'll talk to you very soon. Bye-bye. Hey, I hope you've enjoyed that video. If you did, please do me a favor, hit that like button, hit the subscribe button if you want to see more content. Up here on the left-hand side, you're going to see another video from our this playlist. And if you click down here, you're going to see another video on our channel. Hope you guys all have a great day. We'll see you soon. Bye-bye.